What we're going to be looking at in this video is finding the exponential regression in function, finding the exponential function from a data set, and this is called exponential regression. We had talked about already previously linear regressions, where we give given a set of data, we plug it into the calculator, we're able to actually find the line of best fit, which is what a regression is. And so on this one, we're going to actually look at an exponential regression. So we're going to be given a set of raw data, and we're going to use our calculator to help us find the line or the function that best models the data that we have. So we have this example here. So the first one says, Ms. Stoughton bought $1,000 worth of shares in the Acme Growth Company. The table below shows the value of the investment over 10 years. So you can see the data here. This is the year, and this is the value in dollars of the investment. The first question is to find the exponential regression equation for the data and round to 3 decimal places. So what I'm going to do is I'm going to use my calculator to take this data, this raw data, and find an exponential model or function that represents this data and the behavior that it has. So in your calculators, you're going to actually use the stat function. So the first thing we're going to do is we're going to hit stat. Once you hit your stat button, you're going to select edit. And as we see here, I need to go ahead and clear these lists. You want to make sure both lists are clear. There is an option where you can clear the lists from the stat menu. If you go back to stat and you go down to number 4, you can choose clear list. And then the list names are actually above on this model of calculator, the 1, 2, and 3 keys. So I could have chosen clear list L1 and hit enter, and that would have cleared the list for me. And then I could have done the same thing, go back, stat, clear list, choose L2, which is above the 2 button, and hit enter, and that would have cleared the second list. So anyway, let's go back to our tables. And what we're going to do is in L1, that's going to be your X value, that's your input, that's your independent variable, is going to be the year. So I'm going to enter 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that completes the first part of the table. The second part of the table is the value of the investment, and that's going to be in dollars. So at 1 year, we have 1,045. At 2 years, we have 1,092. At 3 years, we have 1,141. At 4 years, we have 1,192. At 5 years, 1,246. At 6 years, 1,302. At 7 years, 1,361. At 8 years, 1,422. At 9 years, 1,486. And at 10 years, 1,553. So this is our raw data. Now what we're going to do is we're going to ask the calculator to take this raw data and find the best exponential model for this information. So we're going to go back to stat, and then we're going to arrow over to calculate, because we're going to do a calculation now. Now what we're wanting to do is an exponential regression, which is basically telling the calculator to find the line or the exponential function that would best fit the data. It's not going to be exact, but it's going to be close. We've done some exercises already where you've found the common factor, which helps you to determine your b-value for your function. But when you have raw data like this, practical application, most of the time it's not going to be absolutely perfect. So we're going to ask the calculator to give us the best estimate. So I'm going to go to calculate, and then I'm going to arrow down until I find exponential regression, the EXPREG. So again, you go to stat, you go to edit, you enter your values. Your X values go in L1, your Y values go in L2, your Y values being the value of your investment, that is your dependent variable. Then we go back to stat, go to calculate, and we're going to go to exponential regression. Once you hit enter, you've got exponential regression. You hit enter one more time, and there are your values. So if we look at these values that were given here, what I'm looking for is the actual equation. And if you look closely, you can see that it gives you the equation. Now, the key thing is we want 3 decimal places. So, remembering that an exponential function is always y equals a times b to the x, the calculator is letting you know what the a value is and what the b value is. The b value is actually the common ratio. And we'll talk a little bit more about the common ratio when we look at different types of tables. So we have the a value, which is 999.843. So y equals 999.843. That's our a value. Our b value is 1.045. So I have times 1.045 to the x. And again, I got all that information by entering my table into the calculator and running the regression. So this is the line here, not the line, I apologize. This is the exponential model that best fits the table, that best represents and models the behaviors of these values. So now that we have the equation, we can move on and make predictions. So this shows us the value of the investment up to 10 years. Now that I know the equation, I can actually look at the values of the investments at any point in time. So I'm going to take the calculator back. I'm going to go to y equals, and I'm going to go in my y equals, I'm going to graph it. So I'm going to have 999.843 times 1.045, and then I'm going to hit the exponent key to the x, and I'm going to graph it. Now, I don't necessarily need to see the graph, and in order for you to see the graph, you actually have to recalculate your window and go to Format and change your window around to fit your values. But we don't need that here. We're going to use the table to find our predictions. So I'm going to hit Second Graph, and that takes me to the table. So now I can see the table of all my values. And the only values, remember, our domain is going to be 0 because 0 years is the smallest you can have. So 1 year is where we start our table. We're looking for the value to the nearest dollar of the investment after 11 years. So I'm going to scroll down under my X column, which is my years, to 11. And once I scroll down to 11, according to my table, the value of my investment is going to be $1,622, and it's 0.598, so that would be 60 cents. So that's going to be $1,622.60. That's the value of my investment after 11 years, based on the pattern that this model follows, based on the exponential pattern. So now let's make a prediction for 15 years. I'm going to go back down here. I'm going to hit 15, and at 15, the value of my investment is $1,935. And if you want to put this on here, and 0 cents. It's exactly $1,935. So now let's look at 18 years. I'm going to come down to 18 years, and according to this, the value of my investment after 18 years is $2,208. And if you look down at the bottom here, this is where we're looking, 0.132. We're going to round to cents. It says monetary. It's money. So 0.13, 13 cents. Now I've got one more prediction to make, and that's after 30 years. So I'm going to scroll down till I hit 30 years. And the value of my investment at 30 years is $3,744. And then we've got 0.730, so just 73 cents. And when you are looking at these values, remember, you're being asked for significant figures. You're being asked for 3 decimal places. So in this column, you can see the only decimal place that are visible in the column itself in your second list is 1 decimal place. So you actually have to highlight that cell so you can see. If you look at the cell here, I have 3,744.7. But in reality, if you highlight the cell, you look at the bottom, it's 3,744.73011,959. That enables you to round properly and get the most accurate answer. So again, this is how we find the exponential function using a regression based on a set of data. And then once we have our equation, our a value and our b value, remember exponential functions, a times b to the x. Once we have our equation, we can use that equation to make predictions on other values within that model.